Hello, my name is Keshwani. It's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 237. Please turn to it. Page number 237, and today is our lesson number 334. On page number 237, we see system of inequality. We're not going to actually do that particular problem. We're not going to actually do 2.8.3, the two inequalities that are given there. We're going to do, as it says on the blackboard, a bonus problem, which is based on the two equations that we solved yesterday, which you find on the previous page, on the opposite page, on page number 236. And the two equations are 4x plus 3y is equal to 13, and the second one is x plus 2y is equal to 2. What we're going to do is, instead of solving these two as equations, we're going to convert them into inequality, and we're going to ask ourselves, where does the solution region lie? How do we show the solutions to inequality? Yesterday we saw how to show the solution to two equations, and the solution to two equations is very simple. The solution to two equations is just a point of intersection. But when we have inequality, the solution is not a point, but it's infinite number of points. It's a region. One does not talk about a solution when one is dealing with inequality. One talks about a solution region, and we want to find out how to show solution region with these two inequalities. Instead of 4x plus 3y equal to 13, let's pretend that it is 4x plus 3y greater than or equal to 13. And here, instead of equal to, let's pretend that it is less than or equal to 2. Nothing is going to change as far as the starting point is concerned. To start out with, we need to figure out how to plot these inequalities, and to do that, to begin with, we have to treat them as equality. We have to treat them as equality so that we can get the two intercept. Let's do that very quickly. So 4x plus 3y equals to 13. Let me change this marker. This marker is dying. Just give me 1 second. I'm still here. 4x plus 3y equals 13. When x is equal to 0, we have 4 times 0 plus 3y equals to 13. 4 times 0 is just 0. So what we find is 3y is equal to 13, which means y is equal to 13 over 3. 12 over 3 would have been 4, so it's 4 and 1/3. 4 and 1/3. So it goes through 0 and 4 and 1/3. Let's show it here. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 and 1/3. When x is equal to 0, on the y-axis is 4 and 1/3. 1, 2, 3, 4 and 1/3, somewhere here. Let's find the x-intercept now. When y is equal to 0, we did this work yesterday. We are doing it again because this is an independent problem. There's nothing to do with yesterday's problem. Here we're dealing with two inequalities. But we have to start out as equality so that we can plot them first. And again, we have 4x plus 3y equals to 13. And when y is equal to 0, we get 4x plus 3 times y equals to 13. Because y is equal to 0, and we get 4x is equal to 13, which means x is equal to 13 over 4. 12 over 4 would have been 3, so it's 3 and a quarter. 3 and a quarter, x is 3 and a quarter. 1, 2, 3, 3 and a quarter, somewhere here. Oh no, 3 1/4. Now we have to ask ourselves, where does the solution region lie? Does the solution region lie above it, or does it lie below it? Where is our line here? All the points that lie above the line will satisfy this inequality, or all the points that lie below the line. And to do that, the simplest trick is to always look at the point of origin. Just plug in the coordinates of the origin and see what happens here. Let's do that. I need the room, obviously. We need to get rid of it. Look at 0, 0. So we have 4x plus 3y is greater than or equal to 13. It has to satisfy this inequality. But 4 times 0 plus 3 times 0 is just 0. 4 times 0 plus 3 times 0 is not equal to or greater than 13. This point does not lie in the solution region. Just quickly, just to satisfy a curiosity, quickly, we can look at one more point if you like. How about this one? This is 1, 2, 3, 4. How about 4? And we know this is 3. How about this point right here? 4 and 3. Let's put that in here. This part is not necessary. This part, what we are about to do, is not necessary. Once we realize that 0, 0 does not lie in the solution region, if this point does not lie in the solution region, then the solution must be on the other side of the line. It's either this side or that side. If you find one point that does not satisfy the inequality, then it's the other side, obviously. Which is why it's greater than, you see, it's above it. 4 and 3. 4x plus 3y has to be greater than or equal to 13. 4 times 4 plus 3 times 3 is indeed greater than or equal to 13. 4 times 4 is already 16. So the solution lies in this region. This is any points that you find in that region will satisfy this inequality. Now let's look at the second one. The second inequality that we have is x plus 2y Tutor is less than or equal to 2. Again, we have to treat it as, to start out with, we have to treat it as an equation. When x is equal to 0, and x is equal to 0, 2y is equal to 2, and y is equal to 1. So it goes through 0, 1. 0, 1. X is 0 along y-axis, 0 and 1 right here. Again, when y is equal to 0, we have x plus 2y is equal to 2, x plus 2y, y is equal to 0, equals to 2, which means x equals 2, which means x is equal to 2, so it goes through 2 and 0. 2 and 0. Right here. And here's our line. And yesterday what we found was that this was the point of intersection which we found to be 4, 1 yesterday. The question is, where is our solution region? Let's find out. Does the solution to second line that we just draw, does it lie above it or does it lie below it? That's what we have to find out now. Let's do it now. Again, we need the room. So here's this thing, we're done here. We have the line. Now we're going to look for the solution region. Again, the trick is very simple. Look at the point of origin. Look at the point of origin and look at the inequality. Inequality says that x plus 2y is less than or equal to 2. When x is equal to 0 and y is equal to 0, we're looking at 0, 0. When x is equal to 0 and y is equal to 0, does this inequality hold? Is 0 plus 2 times 0 less than or equal to 2? The answer, of course, is yes. It works. 0 is indeed less than or equal to 2, which means this point lies in the solution region. Solution region lies to the below it. Solution to this line lies below it. There you go, there is our solution region. Our solution region is right here. Right in that region. That is our solution region. And just to make sure that this is in fact correct, this one lies in the region, but if you look at 1, 1, this is 1 and this is 1. If you look at 1, 1, if you look at this point 1, 1, you will see that 1, 1 does not lie in the region. We'll see here. Look at 1, 1. Right here, 1, 1. We have x plus 2y has to be less than or equal to 2. 1 plus 2 times 1 is not less than or equal to 2. That point does not lie in the solution region for the second line. The solution is down here. That's it, we're done. That's your solution region. That's exactly what they're showing there on 2.8.3. That's how we find the solution region. But as you can see, it's a great deal of work. If you have to think about every step, if you're not used to it, if you have to think about every step, if you're shaky, if you're not confident, this will take a long time. We have to get used to it, which is why I did an extra problem there, because in the book they just give you one problem, that's it. So here's your bonus problem. Now what I want you to do for tomorrow, before you watch the next video, before you watch 335, day number 335, the next video, I want you to look at this problem that you see there in front of you there, 2.8.3, and solve it yourself. Solve it yourself from the beginning till the end, and at the very end, the solution region that you find, has to look exactly like what it shows here. It should look like this, so neat and clean, just like that, the overlapping area. Solution to one line, here are the two lines here, solution to one line lies above it, solution to the other line lies below it, and therefore the overlapping region is right here, just like we have here, overlapping region. Now just to convince you, I will pick one point in that region, and I will show you that one point, any point in this region, which is why it's called the solution value, this is why it's called the solution region. If you pick any point at all in that region, it will satisfy both the inequality, which is why it's called the solution region. Just to convince you, I'm just going to pick one point and show it to you. Let's see, which point should we pick here? Let's try, we have here 1, 2, 3, 4, how about 5, and this is 1, so how about 5 and 1? 5 and 1 would lie somewhere here. No, 5 and 1 would not work actually. 5 and negative 1 would not work. You see, this was negative 1 right here. So 5 and 1 would not lie in the region. How about 5 and 2 somewhere here? 5 and 2 should lie in the region. 5 and 2 should lie in the region. Let's look at it. Look at 5 and negative 2. Our first inequality was 4x plus 3y has to be more than or equal to 13. So 4 times 5 plus 3 times negative 2, 4 times y is 20, minus a 6, 20 minus a 6 is 14, which is 14 is greater than or equal to 13. You see, it works. 14 is greater than or equal to 13. It works. It satisfies the first inequality. Now we'll show that it satisfies second inequality as well, which is why it's in the solution region right here. 5, 2, 5, negative 2. Second one was x plus 2y is less than or equal to 2. So again we have 5 and negative 2. So we have 5 plus 2 times negative 2. 5 minus a 4 is less than or equal to 2. 5 minus 4 is 1, which also satisfies second region. You see this point right here works. I was about to take this point, but that point right here, if this is 4 and negative 1, then this would have been 2. This would have been 1, 2, 3, 4, 5 and negative 1. 5 and negative 1 does not lie in the solution region. 5 and negative 2 does. 5 and negative 2 does. Anyway, that's how we do it. I know it takes a lot of time because we're not solving the problem for the exam. We are learning the problem. There's a big difference between learning something for the learning purposes, and once we have learned the concept, then to solve it, then it's of course a straightforward matter, just like anything in life. I'll see you tomorrow, okay? Bye now.